So in our last lesson, I told you that intensity is related to loudness. Loudness is related to intensity. So now we're going to put some flesh on that skeleton. And I won't say what we get from that because it's a strange analogy. But let me just talk about loudness and get right to it. So what is loudness? It's our perception, our human perception of the intensity of a sound. Remember, intensity has a specific physics definition. So let's redefine it and then consider the range of intensities that we as humans at this stage of the progression of life here on Earth, that our ears are designed or are capable of perceiving. So here it is, intensity. I is energy per time, that's power, divided by area. Energy per time per area, which is power per area. That's how we defined it. And so units, power is watts, area is meter squared, watts per meter squared. Very, very useful term. Now, the range of human detection of a sound. You probably are all familiar with the idea of being able to hear a pin drop. Now, my old ears are getting less and less sensitive, but I'm still pretty good at hearing very faint sounds, just not as good as I used to be. You know, if I ask you to guess what the intensity is for the lowest level sound that you can perceive, you probably really have no basis for that unless you, well, I guess you could Google it, right? That's what you do with everything these days. That's okay. But it's a lot smaller than you might think. You might think, oh, I don't know, a couple watts per meter squared, maybe milliwatts? 4.2 milliwatts per square meter. I mean, a square meter is a lot. Think of a square meter. That's a huge area. Think of the area of the drum in your ear. That's very tiny. So if it was like 4 watts per meter squared, 4 watts per meter squared, that, you know, spread out over a square meter, that doesn't seem like that'd be very much. Well, here it is. It's 10 to the negative 12 watts per meter squared. Okay, I'm not going to let this get by too quickly, even if you're getting bored with my ramblings, because 10 to the negative 12 is a smaller number than you can conceive of, or at least that you can intuit. It's easy to write to minus 12, but 1/millionth of 1/millionth of a watt for every meter squared. It's insanely small. How can our physical bodies have a system that can actually be sensitive enough to detect that level of intensity? I don't know, but it does. Okay, so that's I'm gonna refer to a pin drop as the smallest sound that we can hear. Now, to the other end, the number that goes in here that I haven't put in yet, I don't know. Okay, if that's, regardless, our ears are sensitive. Okay, so if this is the smallest or lowest level sound that they can hear, what do you think the highest level sound is? You know, that, which really means, I mean, there's no level that you can't hear if it's too loud. It's just that you get to the threshold of pain, and you arrive at that typically at a rock concert. You can get to the level, to the threshold of pain, as it's called. Well, if this is the lowest level sound, you think maybe 10 times louder than that is the most that it would be, or maybe more than that, maybe 100 times. How about 100 times? So think of the smallest sound, 100 times louder than that, or more intense. That seems reasonable to me, but some might say, well, I don't know. I'm thinking maybe 1,000 times louder than that. To me, that seems like, from just a first pass, common sense thought on this, I would think 1,000 times is pushing it for being a sound that you could hear, you know, that would still be less than the threshold of pain from the quietest sound. I mean, 10 times would be really easy to hear. 100 times seems like it'd be really loud. 1,000 times it would blow your eardrums out. Okay. Hope you have an appreciation based on that commentary of the actual value, which is 1 watt per meter squared. All right, so it's not a factor of 10 or 100 or even 1,000. It's not even a factor of 10,000, 100,000, or a million. It's not even a factor of 10 million or 100 million or a billion. It's not a factor of 10 billion, 100 billion, it's a factor of a trillion. Now, I hope you realize that you lost concept completely of what a trillion was there. It is a bigger factor than we can conceive of. I'm repeating myself, but I want to make the point because it's amazing. It's just amazing that a trillion times louder than the faintest sound is the loudest sound before it hurts. We have such a range of hearing that it just is awesome. And it makes you wonder at how amazingly privileged we are, I would say, to live in a world, in a universe, where we have an organ that can pick up a range of sounds over such a broad range. But it leads us to question, isn't that a trillion times? Wouldn't that blow our heads apart? Well, it wouldn't, because this is so small. This isn't really that big, 1 watt spread out over a square meter. But the conclusion I want to come to from this commentary is that it corresponds to 39 doublings from the lowest detectable sound level. You might say, okay, this is the lowest level, double it. Double it again, 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 double it again. When you get to about 10 doublings, I'm sure you'd say, okay, we got to stop because it hurts. Well, you got to double it 39 times for the factor of a trillion, which means our perception of loudness is not proportional to intensity. That's the biggest conclusion we can come to. Our ears have a logarithmic response. When a sound is twice as loud, it's not twice as intense. If we double the intensity, it doesn't sound twice as loud. If it did, our ears would be blown out far before we got to this 39 doublings. It's actually about 10 times as intense if it's twice as loud. If it's 4 times as loud, sounds 4 times as loud, that corresponds to 100 times the intensity. So a doubling corresponds to a factor of 10. That is the logarithmic response. So our ear, we have a formula to match the actual response of our ear. It's a logarithmic scale where the intensity is measured in decibels. dB is the unit. And so we can think of this as beta. Think of that as sound level, or loudness is equal to 10 log base 10 of I over I0. So this is the formula. You may not like logs, but that's it. I'm going to explain it in a second. But the unit is decibel, and I0 in this format here is the threshold of hearing, the minimum audible intensity that can be heard. And we already defined that. That's this 10 to the negative 12. That's up here. So it's 1 times 10 to the negative 12 watts per meter squared. And the next thing to do is to see how this works in calculating values for the loudness and the intensity. And it's really a pretty slick system.